Hello, everyone. Hello, and welcome to xeoMeetup number 4. We are happy that we have you with us here. We'll wait for 1 minute more so that we can gather. I think this time, yeah, as always, but especially this time we can keep it casual. So okay. So yeah, just as a reminder, we use the chat to play some questions, but of course, if there's anything, you can unmute yourself as well and just speak up. So don't worry about that. We are happy to get your feedback. And yeah, other than that, we have 3 topics. All good things are 3. So that's why we have the quick brief by Lindsay today. Just some things that we've been working on lately. Without going into too many details, just to give you a quick overview. One big topic presented by Matteo, CVE scannings and vulnerability management. So what do we do in terms of cybersecurity? So I think it's quite an exciting topic. And yeah, lately we've been working on a lot also on, let's say, the backend side of xeokit. So there will be also some things presented by Fabian in terms of IFC processing, materials, improved geometry, and so on. So I hope that you enjoy it. I sure have, as we did the rehearsals. So yeah, looking forward to exchange, and please bring your feedback, your questions. We are all ears. So without delaying too much further, Lindsay, stage is yours.
Sure. Okay, let me just share. Share. So yeah, I've got a short little presentation here on just 4 cherry-picked new things from xeokit. So I got 3 examples and 1 new release of the Creox IFC converter. So here's an example added to the examples collection by Dian. Dian's been vibe coding here, and yeah, so AI has been really useful for us at xeokit for generating examples and for generating things like unit tests and visual acceptance tests and things like that. So here's an example: visualizing model revisions. So this one is live, and so yep, so we've got 2 models side by side here, and we can look in the side here and highlight. We have 2 modes. We can highlight the diffs between the geometry elements or the properties. And so I won't go into how this is done. I'll just point you to it. And of course, in the bottom left corner, the source code is always available there. So that's one. That's comparing model revisions between 2 IFC models. That's a visual diff of 2 IFC models using xeokit. Here's a second example from Dian. Visualizing the results of the IFC clash detection tool. So this is the tool from IFC OpenShell that runs like offline on your server and creates a set of clash results, and Dian is visualizing these in this xeokit example where we have the results, the clash detection results in the left-hand column here. So we can sort of go between each of the clashes with a note, and at each clash, we can export it as a BCF viewpoint. Yeah, and we can see all the clashes here and visit each clash via its annotation. So this is these use cases are something that our users have asked us many times. How do you recommend implementing this on xeokit? And so here we have some concrete examples of how to do that. So that's clash detection from IFC clash. And here is another one. Here's now for the case when you load an IFC file that just doesn't have color for its elements, and yet it still has classifications for the elements, like say these trees or something like that, but no colors. Then this example shows how to create a table of fallback colors for IFC types, but it goes a step beyond that, and it also infers the IFC type if necessary from the name of the type using a regular expression. So we've got a model loaded here. And this is what it looks like when you, yep, there we are. Here's the model without the fallback colors, the IFC with some gray elements, and this is the viewer applying the table of fallback colors. And my fourth element, we have a new Creox converter. So just a reminder, Creox converter is an offline tool that we provide for converting IFC files into GLTF accompanied by JSON metadata. So this is the first step of our recommended import process for loading IFC files. And so now we have it running on Linux ARM64, which just gives a lot better results, just better performance. And that is over there on the releases page. And this is all I have. That's it.
Thank you, Lindsay. That's the point of having a quick brief, to be quick.
Yeah, these are cherry picked. I mean, we've also made lots of smaller additions, fixes, and optimizations and improvements, but there's quite a lot of them, and they're very fine grained. And I wasn't quite sure how to summarize them here, but they're on the releases notes.
Thank you, Lindsay. So we'd be happy to get your feedback, everyone in the meeting, and any questions.
Can we see the links to those examples in the chat?
Yeah. I'll put those in the chat. Yeah.
Yeah. Okay.
Thank you.
And otherwise, we'll share the presentations after the meetup, as we always do, per email.
Yeah.
And maybe before we continue with Mateusz, just a couple of comments.
Click too fast.
That's, we keep it casual. So two things that I would like to add here on this topic. I think this is the first time that we are sharing AI generated content, and we want to be clear about that and to specifically market as AI generated, so that you know what is coming from where, what is the source of that. So we'd be happy to also hear your thoughts on how we should present this to you. Would be quite interesting. And other than that, I also wanted to mention exactly the backend side of another big topic that we've been busy the last few months. So it is actually pre-announcement right now. So a very exclusive audience here without showing anything, but you just let me know if you would like to get access to the xeokit data engine for Revit. This is something that basically extracts data from a Revit file fully independently from Autodesk. So just let me know. We have a contact form for that, so that you can get an early access to the evaluation version. So it's already there, and you can give it a try. And we'd be happy to hear your feedback. Of course, we will communicate in the next months as well, but if you would like to start early. So that's on that. And then, if there are no questions so far, we move on to Mateusz and cybersecurity. Let's hope the sharing works again. Okay.
Okay. Just a second. Okay. I believe you see
Yes.
my. Okay, perfect. Perfect. Just one more thing to. Okay, now everything should be fine. Okay. Yes, using this this meetup, yeah, we would like to use this opportunity to share some our thoughts, some our approaches to cybersecurity in general, to code scanning, but also how we think about this and what we can do in a relatively small team to deliver software which is which is not compromised in any way. And recently, I think the most famous attacks was so-called supply chain attacks. Yes, it's everywhere. It's not only JavaScript problems. Similar issues are in Python. There are also with other ecosystem like Java. There were also some compromised softwares, and the idea is relatively simple. So somehow attackers compromise one of our part of our delivery pipeline, so either source code or final package, somehow is able to inject malicious code, and then this code is included in our bundle, the one which we publish to, for instance, NPM repository, and then other project, downstream project, pull them and include in their bundle. Maybe this goes even upper in hierarchy. So very fast it's spread over many projects, which somehow directly on or indirectly depends on the first compromise package. And recently, those are things from last weeks. So this CVE, it's paradoxically a security scanner, which was compromised. A light LLM, it's super famous LLM API for working with different LLMs. This is Python, but super famous. That's another. This is the third one. It's type of the name of this event. By this virus, many platforms were affected as well. And when we talking about supply chain attack, we have to have those two perspectives. One is this patient zero, so source of the problem, the package which was initially compromised, and some malicious code were attached to that. And then we have all those virus carrier, which can even without symptom pass it even further in this chain. So that's the brief idea. And then xeokit is JavaScript, so we publish to NPM. We are part of this ecosystem, but NPM has some problem. And this is like culture. From the beginning, it was like that. Small libraries, fast-growing dependency chain because one depends on the other, and then it grows super fast, very vibrant. So a lot of things happening all the time, new stuff. It's difficult to like control this, make sure that everything goes according to the plan. And then we have, plenty of tools. Even if we see on the core one, which allows to manage dependency like npm, pnpm, yarn, ban, and probably many more. So it's very difficult to get like good strategy for organization, for bigger groups to have like sane defaults, sane and secure defaults. So quite often happens that when you install something by npm, you don't even notice that there is some script which ran before or after the actual package is installed, and this script sometimes can do bad things can steal some of your data, send them. So that one of the things which people suggest, try to set in global configuration of npm, ignore scripts. And this sounds good, but then when you think that actually I'm using some other tools to manage my node version, and not all of them respect global location of my configuration, and you don't even notice. You think that you are safe, at least from this type of attacks, but in fact, because you use some third party to manage your node version anyway, those scripts are installed and your computer still can be compromised. That's actually the reality. So it's not easy. Okay, and what is our general approach in xeokit? So we try to minimize third-party dependency. This reduces the surface, attack surface. Fewer dependencies, smaller attack surface, lower risk. That's I think what we do quite well, and in time we use less, not more. That's also quite, I think, a good result. And I believe we are currently quite conservative about adding new stuff. Each new dependency is rather well analyzed, and we are sure what it brings. Is there some additional, I don't know, binary stuff which can be harmful if someone compromises this package? So we try to understand that, and because we have very few, then it's like doable. But this is not good advice for the project which has like plenty of dependencies, etc. And analyzing all this by hand manually, it's not the option. But for us, it works. And we go, I think, even further. We try to actively remove dependency. Of course, what is practical, I can show you maybe right now. Currently, xeokit, when it comes to those which goes to the runtime, so are part of our package, which is distributed to npm, we have just 4. So, and actually there are just 2. So we have this HTML2 canvas, and we have loaders GL to parse GLTF and LAS format. So it's not much, and we of course pin them, so we don't here depends as we do for dev dependency for this minor to be upgraded automatically. Here we like quite carefully update this version when we know this is safe. So that's what we can do, and because we are smaller, this is actually possible. Another thing, it's more like generic. especially in NPM, it's good to use this so-called cool downs. So you set either directly in your package manager like PNPN or whatever you use, this cooldown period, so you don't take the freshest packages which were just published, but you wait a few days so you know that they were not compromised. Because I think I found that most of this big things come out within 3 to 14 days. So if you set your dependency to be pulled when they are older than 14 days, that's let's say relatively safe approach. Of course, this is really up to the developers, because here we don't only exclusively talk about xeokit itself, but you can be compromised in other projects. Like you are, you do some lab stuff, you're researching something, you do some npm install, then your computer is affected, and then it's able to steal, for instance, credential to GitHub, and then using those credentials can push some stuff to your repository, in this case to xeokit. So having these cooldowns helps in such situation, and of course some kind of automation can also help here. I think I can share you that if you configure this dependent bot on GitHub, I will talk a bit more about this later. There is also the settings which set this cooldown, for instance, in this case to 7 days. Then it will not create those automated pull requests with the packages which are younger than 7 days. So that's something which also we try to do. Of course, in our case, it's not the problem, because we never do so fast. We never accept those pull requests so fast. For us, this is more as an alert that there is some new package which might be better because solve something else. Yes, so that's just 1 minute. Sorry, I need to. I
think there was also a quite interesting case of WordPress being hacked with a supply chain attack recently, where someone just bought a bunch of widely used WordPress plugins and injected malware in them.
Yes,
it's crazy what people do to get there.
Yes, and especially if this package is highly used, up to the the whole down chain of project which depends on that. So that's really, the impact can be huge, like 1,000 or more quite fast. Of course, we can also ask question: can we already skip npm at all, this npm registry, and maybe it's possible. It's probably not convenient for that, but it's possible. You can rely on Git. You not necessarily, especially for project which doesn't go so fast, necessarily have to rely on npm. And this is one of the, let's say, approach which we tested already. So, I saw those two HTML to Canvas and those loaders.gl. We can also, skip pulling this dependency from npm, and we can inline, and then we, depends on the Git hash, and we can fully control this, manually copy paste. That's also something possible. For now, we didn't decide to drop NPM, but at least we tested. Yeah, it creates some additional problems, so it's not without trade-offs. But for environment where this security should be should be treated really serious, dropping NPM entirely and relies on the Git itself is doable. So that's just side note. Okay, so that was one thing. Another thing is how we could be as a xeokit compromise is someone stole our credentials. So here it's good practice to use 2FA. I think now GitHub really demands that, but the better 2FA we have, the more secure, the better for our overall security, because that was recently that was the source of many problems. Someone compromised someone's credential to GitHub and then was able to attack from this side. And here another thingy which could be dangerous and actually also used in practical attacks. So if you store locally on your computer your personal access token to GitHub, then attackers can use it. If it gets access to this token, can then do everything what you could with this token. So either not use them at all if you don't need it, or really try to narrow the scope, fine-grain access. It's now possible. In the past it wasn't, but now you can really set what exactly this token does. Another thing is use short-lived tokens. So I'm trying like just one day, because I'm afraid that I forget about it. I still need it for some DevOps related stuff, but yeah, if I'm doing this, I try to keep them super short. So that's another practical reason which we can use. And if you're not really so much in this DevOps operations, CI/CD, plain access with Git and SSH key is sufficient, and then it's much harder to be harmed by attacker in such scenario. So that's another, let's say, surface which we have to take care of. And of course, that's also, let's say, our advantage, or we are a bit comfortable in here, that we can harder the access to our repository, because we have relatively small number of people who has direct access without fork to the to main xeokit SDK. So let's say we have 2, sometimes 3 admins or maintainer roles, and then just typical contributor roles, which really reduce the surface of attacks through the compromise accounts like that. So, but this is our situation. If we are a small team, we can keep the pool of this highly privileged people on very low level. And then again, we can afford to not automate everything. Our releases are not, on daily basis. So we intentionally start the release manually. So there is a full human in the, human is in the loop, decide that this is the good time, and etc. So we have more control of this process. It doesn't mean that we don't have problem and potential risk with that, but it's still human driven. There is no automated releases which was in many cases for those attacks which I mentioned at the beginning. And then, of course, some let's say defaults for xeokit. So we not allow force push to main branch, because yeah, it's insecure, because someone can force push to master, then trigger the deploy the release, then bam, package is in npm and all consumer are infected. So in our case, this force push is not possible. We also try to minimize direct pushes to master, not even force. This is a bit, we tried. There is some issue which we still rely, because in case of xeokit, with the source code, we also delivers those bundles, and as long as this is also part of the source code, we need like extra commit, which is let's say automated. So that's one thing which we still need to figure out, and then we can go fully to PR only to the master, and then we have a selected list of approvals. So that's yeah, quite good line of defense. And of course, in case of xeokit, this is quite important. Every pull request goes through the human, and we have actually, I think right now, 2, maybe 3 experienced developers who accept something before it goes to master. So there is like very little chance that something unnoticed goes to our master branch, which then can be deployed. Of course, we have a relatively small number of commits, and we can afford for such thing. Then, but manual inspection is good. Manual review, human review are super good, but sometimes you need more, especially if you have to inspect all the dependency chain, etc. This is not easy to do it manually. So of course we use automation for that. So those tools which are embedded in GitHub, and then we have a code scanning, which on GitHub doesn't show any issue for xeokit. For vulnerability scanning, we have a few of them right now, but none of them is actually related to the production bundle. This is related to our dev build process, but step by step we also remove it. Probably next days, weeks, we also get rid of all this. So we want to have like 0, but it's not always possible, because this building chain, it's not so thin, and from time to time there are some vulnerabilities, but all of them like inspected, and we understand the consequences here. Yes, a part of those GitHub embedded stuff which are enabled, we also have a second service which we rely on, which is in our case Snake.io. And here we don't have much. We have something in source code. This is actually not, yeah, it shows sometimes something. In this case, very let's say lower risk, but we also monitor this stuff. If here there would be something more serious, definitely we would fix it immediately. For this, that's something which have to, let's say, wait a bit. But this is constantly monitored. If something higher appears, we act immediately. Yes. And when it comes to this supply chain attack, most often the attack surface is actually not your source code, but your CI/CD. And by default, it's not super secure. So you have to carefully think about how your CI/CD works. And but anyway, at least my approach, this is still better than run it locally, where you have no like full traceability. You don't know what you do in other folder, which can impact. So having this fully controlled environment, it's still better. So I believe CI/CD is still the best what we can have today. But we try to do some improvement in or not use things which might be harm. So this pull request targeted, that's this like typical scenario which was used for stealing, for instance, token to NPM registry. So you have a fork of xeokit SDK, and you create a pull request from this fork. You run, then CI/CD action is run, but it has access in this case to some of the credentials from GitHub, from actual xeokit SDK. And by that, if there is compromised code which try to read, scan those tokens, it can take over and use it to publish malicious packets instead of xeokit SDK. So we try to avoid this one. So those are the different type of triggers for xeokit, and for pull request, just use this pull request unprivileged. But this is not, you can be better. I mean, we still not do all of this stuff. One of the good advice is to use like full commit SHA for all your GitHub action jobs. So you don't just use the version, but actually pin it to the commit hash. Then you are sure that nothing happens when the action is running. There are tools which can help with that, to pin those action, or to inspect your locally from your computer. You can inspect your GitHub job to see if there is something which could be improved, or there are used some triggers which potentially are dangerous. So definitely there are things to improve. And when it comes more concrete plans for the next step, is to connect our publishing NPM process with GitHub action, not over the token, but use this OADC, so OAuth flow. Then the token is generated only for the release. This also will help us with the provenance attestation. So this idea that it link your package with your build, so you know that there were no added attachment between what you built on your GitHub action and what actually was deployed to the repository. And then we consequently will try more stuff to harder our release process, like setting up this immutable GitHub release, and so on. Another thing we still, for instance, use, but trying to avoid is, if you have some side development, some experiment which has to go to the NPM because you want to share with some customer, and it goes from other branch. than the master, because from master we only publish this GA. No next stack, no other beta, just GA, and by that you potentially could publish something which accidentally can be pulled by others, and it's not from master. We have to think how to avoid this, but that's also something which is very difficult to easily remove, without controlling many branches. For that, again, we are like just 2-3 people who do that, so it's not a big issue. We can control this process, but in case we have like more, that would be definitely some security risk. Okay, to summarize, know your dependencies, tools, call downs, so not depend on the freshest releases. Eliminate, if you could, long-lived credential. Yeah, and then try to strengthen your release. Yeah, so that's what I wanted to share. I think we are in relatively comfortable situation. We are able to understand what's going on. So we can, when there is missing some automation, or it's difficult to do secure automation, we still can fill this gap by human and do it in the secure way.
Thank you, Mateusz. What are your questions or thoughts, feedback from the audience? Quite a technical topic, but I guess it's concerns us all. Michael, yeah, you have one. Just the reaction. You can always unmute yourself and just speak up if you like to add something or to share or to ask. Leaving some space there. All right. So looking at the time, I am myself also quite interested in cybersecurity, following like the Darknet Diaries podcast and stuff like that. But yeah, looking at the time, I don't want to take too much for that, so I would pass on to Fabian, and then we can always exchange later. So Fabian, you have some exciting things to share from CX Converter. Stage is yours.
Yeah, thank you. Hi everyone, I'm Fabian. I develop the CX Converter, and today I'm going to give a short presentation about some recent developments that have been done in the past few months. And here's a quick overview of what I'm going to talk about. First, quick overview to how the CX Converter works and what it does. Then a quick look into how IFC materials are defined. Then how materials are exported to metadata JSON. Then a quick look into the recent geometry upgrades that have been implemented in the CX Converter. And then some additional entities especially for infrastructure, like IFC alignment, certain geometry types, etc. So the CX Converter is a native C++ application that runs on a server, typically to convert IFC models to DLTF, so that they can be used in xeokit, in a BIM web-based environment. And the converter preserves the element tree, of course, the IFC project structure of elements. And it's doing some mesh deduplication and compression, as well as file splitting for very large models. And converts property set, quantities, units, materials, as we will see later. It runs on Windows, Linux, and ARM, like as Lindsay already described. So this is the typical conversion pipeline, starting from an IFC file. Then the converter generates the GLB file. GLB, of course, is the binary version of GLTF. And we always use the binary version because in the GLB binary format, everything is packaged in one file, which is a big advantage. You don't have to handle separate files, and the buffers and everything is in one file. It's easier to handle, and it's easier to compress and easier to handle the whole thing. And along with the GLB file comes the metadata JSON file, and both are then converted further to be in the xeokit BIM viewer. The materials, which I will mention in further detail, they are exported to metadata JSON, as we will see. Also, properties, quantities, etc. that will be in metadata. So this is how IFC material are defined. So first there's the IFC material entity, which is just a simple homogeneous material. We will see an example in the next slide. And then there's material layers. So in many cases, you need not only one material for a certain element, but layers of elements. For example, if you think of a wall, in many cases, it has several layers, for example, brick or insulation, paint, etc. And yeah, one way to model this would be to have a separate geometric entity for each layer. But then that increases the amount of geometric entities, of course. You have more meshes, the file size is bigger, etc. And that's why in IFC, there's this possibility of defining a material layer. And then, of course, once you have layers, you want to have several of them. That's why there's this IFC material layer set. Doesn't make much sense to have only one layer, of course. Then you could just use one single IFC material. Yeah, IFC material layer set. The set is actually not really a good name. So it's not really a set. It's more like a list. It has a certain order, of course. The order is, of course, important because you don't want to have the insulation at the wrong side of the wall, etc. So increasingly, CAD tools export these kind of layers as separate geometric entities. So each layer is its own mesh, its own solid element, which has an advantage that you can select it, you can hide it, and things like that. You can, click on it and see the property sets, etc., which is not really possible with this layer set. But anyways, the layer sets are there and we have to handle them. And here's an example how they look like. On the left side, you can see an IFC file in the step file format. You are probably familiar with this kind of entities. Very simple format. You can open it with a text editor and look at the entities, and everything is available in the text with the simple text editor. And here in the first line is one IFC material defined, and then you can see the references between the entities and how this layer set is defined. So first the IFC material, then material layer, then a set of material layers. And this is a very simple basic example, but typically you would have several layers, not just one, like in this example. here there's only one in this set. The orange reference, it's only one layer, but typically you would have several of them. Then there's this FC material layer set usage, which establishes the reference between the wall and the material, or it defines how the layer set is used actually. For example, it defines the direction and an offset, etc. Then rel associates material connects this usage entity to the actual building element. So the wall doesn't have a reference to the material layer, and the material also doesn't have any reference to the building elements. Instead, there's this relation object in between, which creates this relationship. And then here on the right side is the same information, but in the JSON file format. So this is what the converter creates. The converter takes the IFC file format and step format and creates the JSON format, which is then usable in the web browser. And as you can see, it's basically the same thing, but in this JSON file, we don't have references. So we have to kind of work around that. Theoretically, you could just expand the object and write it, for example, down there you can see the meta object, which is the wall. And then it has a reference to the material. Theoretically, you could write just the object notation of the complete material in there, but that would result in a very large JSON file. And that's why we created this an additional array with materials, and the wall then only has the index for this material. So I think it's a good compromise to not blow up the file size too much, and also it's quite still human readable and also easy to access from JavaScript. Yeah, if anything is unclear, please feel free to ask questions.
Yeah, there are actually a couple of questions. Should I just ask them, or would you like to unmute yourself, Michel?
Oh, I can see it here.
Oh yeah, recently I came across a lot of IFC files that use a new construct or new construct and not a new but the material constituent set and the profile set also. So, and they are a bit like the layer sets, but yeah. So I was wondering
currently,
if you
currently we haven't implemented them, but that should be relatively straightforward to do. Yeah. So if you need them, I can just implement it in the coming week or two.
Okay. Yeah, I'm going to have a look into this one because this will make our life probably for extracting data just even easier. So yeah, cool.
Okay. Yeah. Yeah, I think this constituent set, it would not break this concept that we have in this current slide. I think it would fit right into there. Yeah, but it's not handled yet on the C++ side. Yeah.
No, the difference between because the layer is like real layers, and in the constituent set you can have a ratio, I guess, if I'm correct. But so yeah.
Yeah, to be honest, I didn't use the constituent set yet. So yeah, but
if you want, I can send you some IFC files that use it quite effectively.
That is good, actually. Yeah, because verifying with a real world IFC file, that is always good. Yeah, yeah. Perfect. Good.
So just you open the ticket through the service desk and share the file there, right?
Yes.
Perfect. Great. Yeah. So, thank you for that question.
Yeah. Good. What about colors? Material and colors intuitively are kind of connected. And in IFC, they can be connected, but they can be also completely separate from each other. So in what the converter does is the colors actually go into the GLB file, not in the metadata file. And in the previous slide, what we saw, that was, of course, the metadata JSON file. And here, the colors which are defined in the IFC model, they go into the GLB file. And this is a bit confusing maybe, because here they show up as material, as we see here. This text example here on this slide is taken from a GLB file. The GLB file is actually a binary file, but it also has text portions like this here. The materials, for example, in the GLB file, they are defined just like this text example here. And you can see the color is there, but the color is not only a color, it has material properties like roughness, etc. And they are defined as materials in the GLB file. And like Lindsay mentioned in the previous presentation, there can be a color mapping. Sometimes elements don't have colors defined, and then in the viewer you can define certain colors. For example, a roof which doesn't have any explicit colors defined, you can just give it a red color with some kind of map. Yeah, you can that would be based on the element type, but you could also do some color mapping based on the material, if there's a material assigned to that element. Here's an example of it's a very complicated example actually, where material and color are connected with this IFC material, this highlighted element there in the middle with a very long name. So this connects the material definition, which is in the top part of this example, and the color example, and the color which is defined below there. So they can be connected, these two, but not necessarily. And color definitions can be also completely independent from material definitions, just with a styled item assigned to like a wall, or even to a geometric item like an extruded solid. So it can be just assigned directly to a geometric item. Okay, then so much to the materials. And here's a few other aspects of recent upgrades. Mostly we implemented some geometric improvements, for example, surfaces which are bounded and at the same time defined on a circular shape, which is very complicated to implement. So which was not properly done in the past, as you can see in the screenshot in the middle, and now it's handled correctly as in the screenshot on the right side. Also, Boolean operations processing is always an issue which creates some headache. So it's a very complicated topic, Boolean operations, and it's never perfect. You always, when something is improved, it always breaks also something. So it's very complicated to achieve improvements there. But we have some progress there, and this is in the last release also. Then we added element types for infrastructure. So increasingly, IFC is used not only for normal buildings, but also for infrastructure projects like bridges and tunnels, etc. And we added support for these types, and especially geometry types like clothoid, etc. Yeah, that's it so far. In case you have any questions, I'm ready to answer if possible. Otherwise, I'll give back to Dian.
Thank you, Fabian. So, everyone, I would say, yeah, these were the 3 presentations for today. But yeah, we are really looking forward to your questions and feedback. It's As you see with, for example, with the IFC, it's a never-ending story of some exotic IFC types and entities, and it's really useful to get your feedback. What is really used out there? What needs to be supported? And then, yeah, we improve together. So, okay, I guess we can say the official part. We can wrap it up. We are here if anyone has any questions, any comments, like to stay in longer. And we thank you very much for being with us today. Looking forward to have you again in the next xeoMeetup. And we keep in touch. Thank you, everyone.